Hello guys, welcome to this video. In this video, we're going to create a doubly linked list together. The only thing I hope you to know when watching this video is basic programming logic and the basic of C syntax. If you already have that, you can come to this in this journey with me because today we're going to create a doubly linked list in C. Okay, so now as you can see, I'm using Fedora. So some steps can change depending on the operational system you're using. But when it comes to writing the code and the syntax, it will not change. Okay, so you can follow the same steps I'm doing. So the first step I'm gonna take is to open the terminal. I'm going to documents, study, because that's where my folder is. As you can see here, I already have a main.c because I have another video I recorded, but I'll remove it. And I'm going to create a text file called main.c. No. Okay, so I have this text editor. In this tutorial, I'm not using any IDEs, but you can use if you prefer. I'm going to define some libraries we're going to need. Okay, so that's our basic C file structure. So what we want to create here is a doubly linked list. I think if you're here, you already know what a doubly linked list is. I am not going to spend much time explaining what a doubly linked list is. The only thing I'm doing in this tutorial is to teach you how to implement the structure, okay? But basically, what a doubly linked list is a list of numbers or any other value they want to store. And this list contains nodes, which every node is pointing to the next node and the previous node. So our list has nodes that is pointing forward and backward. Okay, so let's create our list. First step is to define a struct node. So that's what we're going to do. Struct node. And every node, as I said, will point to the next node and to the previous node. So every node has a node inside it. One node to the next, and another node to the previous. And of course, the key, the value. Okay. As you can see, I used struct node because at this point, the name I defined here for this struct is not defined yet because I only define it at this line. But in this one, this nickname does not exist yet. So that's why I'm still using struct node. But further, I'll use node. Okay. The next step is to create the list itself. So list, okay. And here in this line of the code, I already know that it already knows that node exists. So I can use node instead of struct node. So node, and our list will point to the first node and to the last node. Node, node, last node. Okay. And I also want to store the length of the list. I'm going to create a integer length. Okay, so that's our structure. I think that's all we need to start implementing our list. Okay, so the first step is, of course, to create the list. So let's create a function that will return a list called create list. This function will return a pointer to a list. Okay. We don't need any parameters. We only need to create the list and return it. So list size of list. We're using malloc to allocate memory the size of a list, and we are storing inside this variable. Okay, and now when we're creating a list, our list is pointing to nothing, and the length of it is 0. So list first node null, last node null, and the length of it is 0. Okay. Of course, we want to do that if list is different than null. And else, if it's not, then we're just going to print an error. Print f. It's not. This the list. We're just doing it for some clean code because most of the times it will not happen. I think it will never happen. We have to deal with every situation, right? Okay, so it was not possible to create the list. We created the list. Our list first node is null, the last node is null, the length is 0. And at the end, no matter if it's null or if it's the list, we're going to return list. Okay. Actually, I don't know if we return list if it's null. Actually, I just want to return it if the list is different from null. No, because I'll have to return something at the end. Okay. So we created the list already, and the next steps is to insert an element at the start of the list and print the list so we can see if our list is working out. Okay, so let's first insert start. We need the value that the user wants to insert in the list, and also which list is referring to. That's all we need. Okay, so as I said, each value that the user wants to insert in the list is a node. So when we want to insert something, we have to create a node. So that's what we're going to do. We're going to create a node the same way we created the list above. So node malloc size of node. Okay, I already have a node. And if I want to insert at the start, two situations can happen. Maybe my list can be empty, and it can have a value in it already. So we have to deal with both situations. Let's say that our list is empty. So if our list is empty, then if list first node is null, then our list is empty. And we're just going to actually, before that, let's do what will always happen independent of the situation. Because even though I have to be specific about every situation, I have to understand that in certain value has some commands that will happen no matter situation. So for example, no matter the situation, my node key will get the value, and node next will point to list first node. Node next will point to the list first node. And the previous of this node will be null because I'm certain at the start of the list. So as you already know, I hope you know, our double linked list, the last node points to null and the first node points to new as well, because every node is pointing forward and backward. So the first node, the previous of the first node is null, and the next node of the last is null as well. So in this case, the node P will get the value. The next node of the node we just created is the list first node, because we're going to point to the list first node. It will always happen. If it's null, we're pointing to null. There's no problem. But if it's a node, we're pointing to that node. If the first node, let's say it's different from null. If it's different from null, then there is a value in there. And I need to make this node the previous node of this first node of the list point to the node I just created. So we're gonna do is list first node previous is going to point to node. Okay? Yeah, that's it. Why we're doing it only if first node is different from null? Because if it's null, how can we access the previous of the node if it's null? So that will return a segmentation fault. Okay? I think that's all we need for the first node. And of course, at the end, we're gonna say that the list first node will be node. Let's see if we did everything right. Our node P receives a value. Okay. The next node of this node is the list first node. It can be null or a node that exists. The previous will be null. Okay. If the first node is from the list is different from null, then we're making the previous node of this node that is the first from now. Point to our node, and At the end, we're making the first node of the list, the node we just created. I think that's right. As I did in the last function, I'm going to do all that only if the node is different from null. Okay. And in the end, I can do that. Yeah, I think we're doing great. And I can also print a message in the end. Value inserted. Successfully. Value inserted. Yes. I think it's right. There's nothing wrong here. And now we can make a function to print the list. So print list. The only parameter will be which lists we want to print. Let's put here list. And to print the list, we have to go through nodes. And of course, we're going to use a loop in this situation because we don't know how long our list will be. But the thing is, what can I use to make this loop stop? Because the only thing I know is at the end, the next node of the last node is pointing to null. I mean, it's null. So we can use this information to go through all nodes, and once I get to the end, I stop. So in order to do that, we have to create a node. Actually, in this situation, I don't know if we have to use a pointer, but I'm going to use just for safety. Let's use node malloc size of. Actually, we don't need to use malloc. We need to get the first node. Yeah, that's it. Okay, so we have a node that is just taking the value of this node here. Okay, so we have another pointer pointing to the first node. There is no problem at all. And now you can make a while loop in here. Okay, and this node would just be a reference of which node we are. So while node is different from null. So while node is different from null, I will print the value of the node. I need to put printf. Printf the value node p. So only if the node is different from null. Okay. But before printing the message, we have to put something to make our node change the value, because we're just setting the node as the first node and we're not changing it. So this loop will repeat forever. So how can we go further and go through all nodes of our list? We just have to set node. We'll get node next node. So the node pointer we'll get the next node is pointing to. So the node will change its value. And once the value of node is null, the loop will stop. I think that's all we need. Yeah, I think that's it. Let's see if our function works. We can see some errors, but that's totally fine. It happens. We just need to know what's happening. I'm saying that before compiling because it's so common, and if you're not used to receive some errors, you haven't coded yet. Okay, so let's just use our function. So let's create a list. I'm going to create a list that will receive this list. The name will be my list. Create list. See, that's right. Yeah, that's right. And I'm going to insert at the start of the list. I want to insert the value 2 in my list. We're also printing the values at the end. My list. Let's compile and see what happens. Expected before token on create lists. Okay, I haven't put a semicolon here. Okay, so it's not next node, it's actually just next. I just remember. Let's compile again. Okay, we can main value inserted successfully, and we already have this my list. So if we're starting at the if we're inserting at the start of the list, then we just see if it's working well. I'm going to insert other values. Okay, just see if it's working. Let's compile again. Okay, as you can see, I inserted 2 first, and then 4, and then 6. Totally right. Okay, but there are 2 other things I want to do with my lists, with my double linked list, is to insert at the end and also to remove a value. So let's do that. Void insert end. I'm gonna do the steps, and let's insert the list. Most steps will be the same as to starting at the start. Okay, so I'm just repeating the code. I'm going to create a node as well. And if node is different from null, node key will get the value. Node next. Here are some changes. Okay, so if we're inserting at the end, actually the previous will be the list last node. Okay, and also node next will point to null. So there are some differences in here already. And if list last node, if the last node is, let's say, in the first situation we have list first node different from null, but in this case we have to use last node. List last node is different from null. Yeah, because in this situation we want the the next node of the last node to point to the node we just created. But if the last node is null, there will be no next of the last node. So yeah, that's it. Last node is different from null. Then we're making it, we're gonna make list node next pointing to our node. Okay. The previous will point to another node that we don't have to care about. And list last node at the end will be our node. Yeah, let's see if we did everything right. The node will get the key. The previous will be the last node. Yeah. Even if the last node is null, because our list can be empty, point to null, that's fine. And the next will also point to null always. If the last node is different from null, then next will point to the node. Okay, that's totally right. And I think that's all. Last node will be the node. Yeah. So I hope you're visualizing all what I'm saying in your head, in your mind. Okay, so at the end we just have to print value inserted successfully as well, just as I did in the function successful. Okay, that's it. Let's try to insert something at the end. See if it's working. So insert end. Let's insert 10 in my list. Insert. Oh, there's a problem here. There is a problem here. I used insert end, and as you can see, where is my value? Where is it? I compile again. I inserted the 4 successfully. At least should be successfully. But we have a problem. And we have to find out what problem is that. Let's see. The thing is, it is inserted successfully. At least it should. But the thing is, my print list, well, it's not showing the value. And why is that? Why is that? I don't know. I don't know if I'm forgetting something. I think I'm forgetting something. If node is different from null. What if we have to say if this first node is null? Because then if this first node null, we have to say that the first node and the last node is we're going to change. It's going to change. Yeah, I think that's the thing. Last node will point to our node as well. And the same thing here, because I mean, let's see if it works. Let's first see if it. Okay, that's it. Okay, guys. So I forgot something. As we insert in the list, if the list is null, we have to say that, for example, if the first node is null and we're trying to insert at the start, we're going to deal with the first node. But there are some situations where the list is empty. And when the list is empty, you need to say that the last node is your node as well. Because if I only say the first node is node, the last node will be pointing to null when your last node is actually your node. Because if the list only has one value, then this value is the first and the last node. So we're going to do it here too, because else if actually it is different from null or it is null. So I don't think we need this else if. So else, if it's different from null, then it is null. Else lists, in this case, the first node is node. Okay, now I think we're good. Let's see. Let's compile. Let's try to revert the logic here. Let's try to insert 99. Inserted 99 and then 2, 4, 6 and 10 at the end. Yeah, that's right. Okay guys, so now we already can insert values, print the values, and the last step is to remove a value. Okay, so let's remove. Void remove list from list. We need the value we want to remove. Okay, so let's the value and also the list we want to remove it from. Okay, so which are the steps? We need to find the node, make the next node the pointer to the previous node of the next node, the node we want to remove points to the previous node of the node we want to remove. It's kind of confusing, but I think you understand when I start to do it. So first step is to find the node. Okay, so we're going to create a node that will get the list first node, while node e the first thing we have to, if node is null, we're going to say that the print f the list is empty. There's no way to remove a value of a list that is empty. I'm going to return. But if it's not empty, we're gonna see the key. Okay, while node key is different from value, we're going to go further, going through the list, searching for the value. Okay, so let's make node we'll get node next until we find it. Once we find it, this while will end, this loop will end. And after we find the node we want to remove the value, because in this case we're going to remove the first node we find in the with this value. Okay, so let's say that we already have the node. Okay, in this case we are in the node we want to remove. So what are the steps we want to take? The thing will be just like this. The node next previous will point to my previous node. Okay, so I am a node. I'm pointing to the next node. This next node, the pointer to the previous of the next node, I want it to point to my previous node. Okay. Also, previous next, I want it to point to the node next. Okay, so we already have these things pointing at each other. This next, these nodes around me pointing to each other. And now I just want to remove my node. Okay, so the only thing we have to do is to free the node. We don't need it anymore. Is that it? I don't know if I'm right. Maybe I think I'm forgetting something, but that's the main idea. Now I just need to see if everything I'm doing is right. Maybe I'm forgetting about some situations, like if the list only has one value. Yeah, I think that's something we should be scared of, because let's say it only has one value and I want to remove it. How can the next node will be null? So there's no way it has a previous node, for example. So if node equals null, the list is empty. If this node equals list first, it actually is the first node. If node list first node, it's not null. But if the node, if it already has a value, I mean, if node equals value, okay, then the first node already has a value. So we need to deal with this situation. The thing is, I only have to free it and make the list first node points to null. List last node points to null as well. And free node. We are repeating code here, I guess. Let's just free the node. And here we can return. Okay. Undeclared node list first node. Oh, okay, I'm using my list here. That's right. List. Okay, it's compiling at least. Let's call our remove from list from list the value, let's say 99, my list, and see what happens. Okay, we are removing. But to make our tests, let's try to insert something after we remove. I'm going to insert 55 at the start. I'm going also to insert at the end 78, my list. And I'm also going to remove from list the value 6. And I'm going to print it all. Okay, let's see what we have here. We inserted 99, then 2, 4, 6 at the start, and 10 at the end. We removed 99 from the list. 99 was here, as we remember. Then we inserted 55 at the start, 78 at the end, and we removed 6 from the list. Yeah. So it's working. I think it's all good. I think we did it right. That was my double linked list tutorial. I know it was a journey because I had some questions throughout the tutorial, but I think it will help you to understand how double linked works. And it was kind of difficult to me because it's been a while since I do this, but I really hope it helps you. And that's it. If you have any questions, you can ask here in the comment section. Hit the like button if you like this video. That's it. Bye.